Hello, our names are DeiuliiSnell and DeiuliiSnell. This is the beginning diagrams and gestural drawings of our project for Architecture 401, Tensile.
This drawing is meant to demonstrate the potential robotic inhabitation of our proposed facility. Our thesis, a hope to challenge the pedagogy of robots as purely a means of making art, or robots as purely tools of industry, and task them to functioning as both, is explored through this architectural intervention.
The site is located at 120 East 5th Street in the historic East Village of Des Moines. It sits adjacent to a formerly dilapidated but historically significant train depot and inactive rail line. As a part of our proposal, we are suggesting that the inactive rail line gets rehabilitated as a means of transport for our production facility.
At the onset of this semester, we were tasked with researching 3 significant contemporary design robots, including their production process and their spatial requirements. Through this research, we became familiar with Maria Jablonina's MoFres robot, a string-weaving multi-species robot. This diagrammatic exploration for work was meant to be an analysis of body standards and their interactions with different robotic species. In their current form, Maria's robots function through a system of vacuum suction or magnetic force. They have been used primarily, to date, as means of artistic intervention. They often result in experiential displays.
The required program for our facility includes robotics labs, an educational suite, an administration suite, a research suite, and public spaces. In these initial massing diagrams, we explored what the required 30,000 square feet looks like.
At this phase of the process, we felt that we had relied too thoroughly on our initial massing as a point of inspiration and went back to gather further design. Motivated by the aesthetic appeal of a model made at the beginning of our careers as architecture students, we began to consider the MoFres robot as one of the main architectural aspects of our site, rather than a robot hosted by the facility. In our thesis, we had considered the implications of robotics being used as more than purely art or purely production. From there, we made the move towards robots acting as a means of production and framing the process of production as art.
With this goal in mind, we are proposing that a central tower that's flanked on either end of the site by gridded track systems, each of which facilitate the type of movement required by the MoFres robot that moves through the process of weaving. On either side of the central tower, we propose that the adapted MoFres robots can work on a process of a large-scale weaving to produce the bones of a large-scale building material cast. The intention here being that the research is focused on means of producing functional building elements on a scale that is not currently possible.
We believe the process of making occurring on the site would go as follows. 1, determine the desired form to be constructed. 2, determine how the form needs to be woven. 3, determine if a new or existing robot is needed for the task. 4, fabricate the necessary robot. 5, allow the robot to complete the woven structure. 6, create a rigid mold within the woven form. 7, cast the form within the mold using a multi-axis system. 8, cure the form. 9, remove from the mold. And 10, send to the final location.
This diagram shows the proposed process of production in action on our site. It also depicts the constant changing of facade conditions that is intrinsic to this process. Each side of the site is independently functioning, which allows for 2 completely disparate stages of this process to be occurring simultaneously.
At this stage of our proposal, the wall system we believe will best facilitate our concept is a multi-layered curtain wall, steel grid, and anchoring peg system. The robots will inhabit the middle layer, while the cords will interact only with the anchoring peg layer. Ideally, this wall system will allow for an aesthetically pleasing view into the midst of production from the interior spaces of the building.
Also necessary in this proposed system is an overhead multi-axis caddy robot. This would act as an intermediary between the 2-dimensionally functioning robots on the gridded structures. These robots would carry the cord back and forth between either side of the production field. We imagine that the gridded structures on either side of the site and on the center tower are functioning independently structured pieces. They will not be reliant on the structure on the central tower, as their load-bearing capabilities will transform so frequently.
The circulation of the space implies a travel through the public and production spaces before leading into the central tower.
With our current conditions, we feel that the elevation and exterior aesthetic of the building itself is lacking. We are concerned that the building is overly reliant on the robotic production as a means of visual interest. As we come to a close with this presentation, we ask for some suggestions on how to address this concern.
Thank you so much for your time. We look forward to hearing from you.